Okay, hi there students. Today's lesson we're going to be looking at using Pythagoras Theorem in 3 dimensions. I've got my little boy Finn with me. If you hear him laughing or Paw Patrol in the background, that's what's going on there. Okay, so if we shift over and have a look at the learning focus for this session, we're going to use Pythagoras Theorem to calculate distance in 3 dimensions. So by calculating it in 3 dimensions, it ups the difficulty compared to what you would have done last year. Okay, so moving on, we're going to do a little warm-up question to review what you would have done in class yesterday. So the mind your head sign shown on the right of the page is an equilateral triangle with a side length of 30 centimeters. What we'd like for you to do is to find its area to 2 decimal places. So hit pause, I'll have some orange juice and then we'll keep going. Okay, so I'm going to have a look at the question and sketch the information that I know. So I've got help if I change to a pen. I've got an equilateral triangle. I know that its side length is 30 centimeters. It's equilateral, so all 3 sides are the same length. I also know that it's an area question. I know that area of a triangle, so area of the sign, is going to be given by base times height divided by 2. So what I don't know at the moment is the height of the triangle, but what I can do is split that sign into 2 right angled triangles to give me a side length down the middle where I can figure out the length of, and I'll show you what I mean by that. So I'm going to take just this triangle here that I'll pretty ordinarily highlight. So that's going to give me a right angled triangle with a hypotenuse of 30 centimeters, a base length of 15 centimeters because it's half of 30 along the bottom. So because I've partitioned it into 2, the length along the bottom is halved, and then my upright length, which I'll call B, I don't know yet, so I'm just going to call it B. So writing down the formula for Pythagoras' theorem, a squared plus b squared equals c squared. I'm going to fill in the information that I know. I'm going to substitute it in there. So 15 squared plus b squared equals 30 squared. And again, Pythagoras is pretty much assumed knowledge for this one, but we can go back and look at the other notes if needs be. So then rearranging that, I could say, well, b squared is going to be given by 30 squared take away 15 squared. So then therefore b will be given by finding the square root of 30 squared minus 15 squared, which turns out to be 675. Now if you work out what that is as an actual number, it's going to give you a pretty long series of decimals. It looks like it's going to be a non-terminating decimal. So what I recommend you do for the next stage is just leave that answer as square root of 675. That way you don't lose any accuracy by rounding twice in the same example. And I'll show you what I mean by that. So then I've got my triangle that I started with, the equilateral triangle, the sign. I know that its height is the square root of 675 in centimeters. And I know that the length of its base is 30 centimeters. You okay there, mate? Finn's playing with his cars. He's a good boy. So know that the area of that sign is going to be given by base times height divided by 2. Yes, please. So that area is going to be given by 30, so the length of the base, multiplied by the height, which is the square root of 675. I'm going to divide that by 2, which gives me an answer that I've worked out previously of 194.86 centimeters squared to 2 decimal places. So that's my answer. I chuck a nice yellow highlight through that. Now we're going to move on to the actual bulk of the lesson. Okay, so again we're working on Pythagoras in 3 dimensions. That's our main focus for today. So by using Pythagoras in 3D situations, it really kicks it up a notch difficulty-wise into the year 10 sort of level. It also it makes it more likely that you'll use it after school because 3D situations are real life situations, so it's perhaps more likely that you'll use this if you don't go down the science engineering pathway. Okay, so on the right hand side there, we've got a rectangular prism. It's got some side lengths on there. We've got 10 centimeters, 5 centimeters, and 6 centimeters. But what we need to do is find the length of AG. And it's kind of hard to show, but AG is diagonal from that back left corner A down through the shape to the bottom right hand corner G just there. So we've got a couple of things that we need to figure out. Yes, mate? What I'm going to do now is draw a couple of things here. So that diagonal that I've just included, what I'm going to do is bring this down here between A and E, and then bring another diagonal across from E rather to G. So what I've drawn there in 3D is actually a right-angled triangle, and I'm going to sketch this just here. So I've got A, E, and G. And a big diagonal down the middle. And that's a right-angled triangle. Now there's not a lot that I know about this triangle just yet. I know that it's got a height of 6 centimeters. I can get that from the diagram from BF just there. But I don't know the length along the bottom. I'll call that Y. I don't know AG, which is the actual question. I don't know what that is. I'm going to call that X for now. Okay, so that tells, if I've only got one known and two unknowns, that means I can't actually solve this this problem. Yes, Van? Excuse me, what I'm going to do now is create another triangle. So I'm going to go E to H, I'm going to go H to G, and I'm going to go E to G across here. So notice that EG line I've used twice, and that's deliberate. So I'm going to draw this triangle again. So I've got H at the bottom, if you like. So bottom left is H, bottom right is going to be G. Oh, my fancy lamps run out of power, that's fine. I know that length from the diagram is 10 centimeters. The height of the shape, so EH, from the diagram I know that that's 5 centimeters as well. And EG, that I've also got on this shape just here, I'm going to call that one Y. So if I can find the unknown in the diagram on the left, I can use that to find the second unknown in the diagram on the right. You can in a few minutes, mate. Finn wants to empty his potty onto the grass. He's gonna have to wait. This is gonna be harder than what I thought, actually. But that's fine. Okay, so what I'm gonna do first, I'm gonna say that for my diagram on the left, so again, Pythagoras Theorem, a squared plus b squared equals c squared. So for this diagram, it's 5 squared plus 10 squared is going to give me y squared. And then, not really rearranging it, but just swapping what side I've got it on. Now I can rewrite that as y is equal to the square root of 100 squared, sorry, 10 squared, which is 100, plus 5 squared, which is 25. So square root of 125. I'm actually going to leave my answer like that, because if I found the actual proper answer, like a decimal, like numeral answer, it gives me a non-terminating decimal. So it's much more accurate just to leave it as square root of 125. Okay, what I'm going to do now is reapply that to my other question. So again, the distance between A and G is what I'm actually looking for. That's the question that I have to answer. So what I'm going to do now is say a squared plus b squared equals c squared. Fill in what I know from the diagram. So let's say a squared can be 6. Y I'll make b, so that's the square root of 125 squared. Because even though it's the side length, it's still something we have to square. So it seems weird to then square it again, but that's what we do for Pythagoras. I'm just working to the formula at this point, and that's going to give me the length of the hypotenuse squared. Therefore, length of the hypotenuse squared is going to be equal to the square root of 125, because those two things will cancel each other out. 6 squared is 36. So my answer is going to be equal to the square root of, well, 125 plus 36, I've done that already, which should give me 12.69 centimeters to 2 decimal places. So again, because it says work out the length of AG, in this working out, I can just call that AG along the bottom here. So it's to say AG equals 12.69 centimeters, 2 decimal places. Or you can replace C with AG through your working out as well. I've just kept to the C through here just to, you know, make it very clear I'm doing a Pythagoras related question for this one. Okay, moving on to example number 2. So I'm building some sandcastles at the beach with young Finn, and I've decided to increase the fun by making it a maths thing. That's absolutely something I would do. So your job is to help Finn escape the situation by finding the diameter of the base. Okay, so looking at the diagram, we've got a sandcastle sort of shape. We're given the height of it, which is 30 centimeters. We're given the side length, which is 32 centimeters, and we're given the diameter of the top, the circle at the top, which is 20 centimeters. So what I'm going to do is redraw the middle cross section of that. I'm going to try and make it fairly big so it's easier to see. It's not as even as I wanted it to be. It's pretty close though. Okay, there we go. All right, now what else have I got? I'll fill in the information that I've got from the diagram. So the diameter of the circle at the top is 20 centimeters. So I'll fill that in there. I've got a side length of 32 centimeters. I'll just do that on the right hand side for now. Now if I partition these sides here, I can put a right angle triangle here and here as well. I know that along the bottom there we've got 20 centimeters because it's the same as on the top. Now if I can find the base of the base length of the triangle, because they'll be the same on each side because I've halved it, and add those together to the 20 that I've already got, that's going to give me the diameter of the entire base and therefore the answer. So that Y there is what I'm looking for. Yes, Finn? This is Finn, my little boy. Can you say hi?
Hi.
Can you look up here?
Hi.
Hi. What I do now is work out what the length of X is. So I'll put in my general Pythagoras formula there. You don't have to do this every time, by the way, but I'm just doing it to make it very, very clear what I'm doing. So I've got my base length, and I do know, oh, I've got my 30 centimeters here. 30 centimeters squared plus my base length, X squared, is going to be equal to the length of the hypotenuse squared.
Dad.
Okay, so rearranging that, I'll get X is equal to the square root of 32 squared subtract 30 squared, which will give me the square root of 124. Now I'm not going to find out what that is as a numeral for the same reason as before. It's much more exact to keep it this way. So now what I'm going to do to find my length along the bottom here, so that's my Y length. Y. Finn, can you say Y?
Y.
Can you say Y equals?
No. Y poop equals.
Y poop equals. Can you say Y equals 20 plus 2 times the square root of 124? So doing that, referring to my notes, should give you, I'm nearly finished, I promise, 42.27 centimeters to 2 decimal places. That's awesome, mate. Good job. Okay, so check that against your answer. Hopefully you got the same one. Now you'll have some questions to try. I'll go back to doing this drill thing with Finn. And I wish you all the best. Finn, you going to say bye-bye?
Bye-bye.
Bye-bye.
Bye-bye. Bye, stop that.
All right.
That.
Hey Finn. Hello.
Cheese.
cheese.
Cheese.